Hello everybody, my name is Shashank, Master Teacher of Mathematics at Vedanta. We are presenting solutions for JEE Advanced 2019, Paper-2. In this video, I am going to present a very nice question asked in the paper from the chapter Permutation and Combination. Let's have a look at the problem. It says 5 persons A, B, C, D, E are seated in a circular arrangement. If each of them is given a hat of one of the three colors, red, blue and green, then the number of ways of distributing the hats such that persons seated in the adjacent seats get different colored hats is. Okay, so the arrangement is circular and the condition is no two persons seated consecutively should get the hats of same color. So see, as the figure is not big here, I mean there are only 5 persons and only 3 colors are used, we can solve this question by making few cases. There is another way of solving this question apart from making cases, that is idea of principle of inclusion and exclusion. So I will consider that as second method, right? In the first method I am going to discuss it just by making cases. See how can we solve it easily by making very few cases. See, there are 5 persons and 3 colors, red, blue and green. Thinking about any particular color, how many times it can be used maximum? Red, suppose red can occur maximum twice because it can be used maximum 2 times, because if it is red, if it is used 3 times, suppose I am giving red color hat to the person A, then I'll have to give red to C at least. I mean, red should not be used consecutively now, so it can be used alternately, right? So red is given to A, then to C, then to E, but A and C, as this arrangement is circular, A and C are seated consecutively. Like suppose I make a circle here and A is here, B is here, C, D, E. So E and A are consecutive, right? So obviously any particular color cannot be used more than 2 times. So obviously there can be 3 finally cases as far as how the colors are used is concerned. So what are those 3 cases? Either 2 red, 2 blue, 1 green is used, or I am writing it, colors used should be 2 red, 2 blue, 1 green, or it can be 2 red, 1 blue, 2 green, or 1 red, 2 blue, 2 green. So if we find number of possible ways of putting the hats, 2 red hat, 2 blue hat and 1 green hat with the condition that no 2 consecutive persons are getting same colored hat. So if you get the answer to the first case, as these cases are equally likely, so for the final answer we will multiply the number of cases we are getting in the first case by 3 to get the final answer to this question, right? So, and in the first case, how can we send these hats, use these colored hats to these persons, in what manner, so that no 2 consecutive person getting same colored hat? Thinking about this single color G is going to any one of these 5 persons, A, B, C or C, D or E. So there are 5 choices for green colored hat. It goes either to A or to B or to C or to D or to E. So for green we have 5 choices. Out of those 5 choices, considering the case when G goes to A, suppose. So for this G has 5 choices. Green color hat has 5 choices. Then after that, this is fixed, right? Green is there. Now for remaining 4%, we have 4%, 4 hats, 2 red, 2 blue, but 2 consecutive color cannot go with, 2 same color cannot go with consecutive person. So if you start with here with red, then we have to put blue here, red, then blue. Or the second case is, okay, if you start with blue, then it should not be blue, it should be red, then it should be blue, it should be red. So either red, blue, or blue, red, blue, red. So final answer to the first case is what? 5. Answer to case 1 is equal to 5 into 2, that is 10. And how many total cases were there? Such cases were there? 3 cases. So final answer to the question would be 10 into 3, that is 30. So 30 should be the final answer to this question. Every cases are considered in easier manner. So I hope you understood this solution. And coming to the second method of solving this question, what I was explaining in the beginning of the video, that is principle of inclusion and exclusion. Suppose like method 2, we can consider A, B, C, D, E. A can take any of the colors, like what was the different colors, I mean red, blue and green. So A can have red or blue or green. So for A, the possible colors, colored hat for the, I mean there are 3 possibilities. So 3 ways for giving a hat to the person A. Suppose A is taking red. So for B there are 2 choices, because whatever color A has taken, B would not take that color. So we are, I mean, filling this in this manner, in clockwise direction. For B there are 2 choices. For C again there are 2 choices. Whatever color B has taken, C would not take. So for D again 2, for E again 2. So in that manner we will get 3 into 2 raised power 4. But the problem is, this looks very easy, but the problem is, suppose whatever A has taken, whatever color A has taken, it might happen that E is taking the same color hat. That is the issue. So for that, suppose we'll have to subtract that case. And how many those cases are there? Suppose, so there are three choices. So we can combine A and E together, right? A and E as single unit. So as if there were 4 person, A, then B, C, D. So in the similar manner, we can write here 3 into 2 raised to the power 3. Again, as we know what is the principle of inclusion exclusion, what we have to do. So the next thing, similar consideration for A, E, D having same color, we'll have to add it. So it is 3 into 2 square. If you know the idea of permutation combination, principle of inclusion exclusion, very important topic in permutation combination chapter. So you can easily get what I am writing here. So finally, A, E, D, C in same color, and obviously in this first case, total case, we have considered that A and B at least are getting different color. So finally there would be total 4 terms in this sequence. So taking common 3, then 16 minus 8, this must be the answer to this question. Plus 4 minus 2, that is what? 16 minus 8 is 8 plus 4, 12 minus 2 is 10. So we are getting 3 into 10, that is 30 is the final answer. So if the figure were high, I mean number of person were high and number of colors, then we can easily make a general expression for the answer in this manner. I mean using the idea of principle of inclusion exclusion. But as the figures were simple, figure was not high, only 5% and 3 colors were there, we can easily make the cases and get the answer to this question. So I hope you understood both the methods, and you enjoyed the solution. Whatever I have explained is also in typed form here, you can go through it. The first method is explained here in typed form. I hope you understood it. Stay tuned for the next question. Thank you.